anyone that's been coming along to the Drake's lounges or participating in the online mailing list will be aware of the telescope that I've been making using a solar cooker parabolic reflector, which I got off eBay. So I thought today would be an excellent opportunity just to update people on where I managed to get with this. So I happen to quite like this picture showing my observatory in the snow, apart from the fact that my attempt at doing an interferometer there has got the dishes pointed in the wrong direction. So how do I move this on? Excuse me, I have to move the script. So this is where I'm located. Hopefully you can see this presentation. You can see this map, can't you guys? Yeah, somebody give me a
Looks
thumbs up.
great.
Yeah, so I'm right in the middle of the UK, which you probably aware is not a particularly big place. So right in the middle, there's the civic city called Birmingham, about 300 miles away from the coast in either direction. I'm just above it. So this is a very sort of quite a highly populated area. Around this sort of area, around about 10 million people are living. So it's hardly the world's most radio quiet place. Although we do have some fields that we can get to within a relatively easy drive. This really is what got me started in and led to me joining SARA around about a year or so ago, when I actually came across the scope in the box in a box project. And if there's one thing I would like to congratulate SARA and other US projects for particular is the absolutely fantastic instruction manuals that are written, which are written in clear language that they don't talk down to people, but they don't expect also a very high level of knowledge, which unfortunately here in the UK we have a bit of a tendency to do. And also then the amazing support that you get, particularly from people in this group. So I've got a lot of people to thank for where I've got to at the moment, mainly because I'm actually, as everyone knows, pretty incompetent at doing anything. So without everybody else, I wouldn't have got anywhere. But the Scope in a Box project has, of course, revolutionized the ease with which people can get involved and do these things. And although that particular project involves sending out people a load of equipment off Amazon US, which is not available outside of the USA, the components are very easy to source outside of the US, and it's quite easy to get a list sent to you. So this is my idea of a block diagram of a hydrogen line telescope. Wolfgang, please don't tell me off if I got it wrong. But so for those who haven't done it before, so you've got there's been a lot of talk about it in this conference, but it's started at real basic level because that's basically where I'm at. So you start off with your dish, captures your signals, and then you have that some sort of feed in that turns it into a signal that goes down your signal on the coax. Before you get there, and I learned this the hard way, you need to stick your low noise amplifier as close as you possibly can to that feed point. For ages, I had mine located at the other end of the coax, which I managed to still map the Milky Way, but it was amazing how it managed to improve the signal strength by just shifting it closer to the feed. So on there, so I've got some KMR 400 coax, which is clearly quite expensive coaxial cable. I bought that when I had the new Alex Sawbird there on the wrong end of the coax trying to compensate for it. And I think now I could probably get away with something a lot cheaper if I wanted to, but I've got it now, so I may as well. And then you have an SDR, and as is in the Scope in a Box package shows you, you don't necessarily need a very expensive one before it then goes into your laptop. So the total cost of doing this can easily be done for, I would say, around about £200 here in the UK. So I don't know, like $200, $250 there in the States with readily available components off quite famous online sites, but easily sourceable around the world. And as far as a laptop, or I use micro PCs, there's little tiny little things that sit on the desk, and I have a stack of them for each of the radio experiments that I'm doing. They're readily available, again, easily off eBay or similar sites. You can buy them secondhand, but pretty much any old computer that you've got hanging around will do the trick. And it runs in Windows, or you can run it in Linux or whatever you fancy. You really do not need anything with any power. So this is a project which pretty much anybody can get involved in. And if anybody's interested, we have a H-line group now running that meets once a month, and you'll be more than welcome to join us to get support if you'd like to do that. So talking about this parabolic solar cooker. So here's the thing. When it arrived, I made sure it arrived when my wife wasn't there. Otherwise, she'd have had a shock of her life if she'd seen that in the kitchen. You can see a rather big thing if you're used to something a lot smaller. Wolfgang's been talking about 25 meter telescopes, but for most of us, 1 meter is a reasonably large thing. So 1.5 meters was certainly pushing the boat out as far as I was concerned. But you guys are lucky there in the States. About $50 to $70. You could just buy them off eBay with a little bit of postage on top of it. They're not readily available on eBay here. But I was lucky that one day I went on and found somebody who was doing a house clearance and had a couple of these for sale. So I then became the proud possessor. So when you buy them, this is what they're supposed to do. They're actually sold for supposed to go on camping with outside. And you should see that you stick your kettle there or a pot at the prime focus, and it heats it up. Even though we don't have very much in the way of sun here, I learned this the hard way a bit when I walked past it one day, and I felt my legs start to burn. So it seems to be quite an effective system. Then you need some place to mount it. I am not a very exacting person. A lot of people here are, and they make things very precisely. But for me, hammers, nails, and a saw is what about as far as I go. Actually, I've got 2 other hydrogen line telescopes, and one of them is the one that you see there up on the right-hand side, which is a Ptarmigan ex-military array 4x4 dipole, which is where I got started on all of this when somebody gave it to me. But so I just use these very simple wooden mounts, which you can easily make in a day. A few old bits of wood from your local hardware store, any offcuts, and just change the elevation by changing the hole that I use on the side. The only thing that's changed for these since is a few more coats of paint, and the sticks on the side have a lot more holes, so I can change the elevation a little bit more precisely. And then I use an inclinometer, one of these digital inclinometers, to precisely measure the angle, and a compass to make sure it's pointing whichever direction I want. And the software will do the rest. And using drift scans, pointing one direction, just leave it for 24 hours, and the software then calculate all the points in between. And that's also what's revolutionized everything. So there we are. It's a picture of my three hydrogen line telescopes there, the Ptarmigan array, the solar cooker, and on the right-hand side is one of Alex Pettit's 13-element Yagis. So in terms of my waveguide on this, I asked ChatGTP to draw me a picture, as I can't draw. The picture looks okay to me, with the one exception that I don't know why it's got a drill bit sticking up the middle from inside the antenna, but still.
It's artificial.
I don't know why it's got that, but still, basically we're doing an old coffee can. So my biggest problem with this was trying to actually get a relevant coffee can, because we tend to use much smaller and coffee sort of glass pots around here. But eBay again was a good source of some of these things, and again very easy to make one of these using measurements which were provided on the SARA forum. And here we are. That's mine. And the probe in the middle was made from a very expensive straightened paperclip on a chassis connector. So you really don't need very much. The distance from the paperclip down to the bottom I believe, is quite important, but the actual size of the can isn't so vital. Originally, I built that as meant to be a separate aerial in its own right, but it didn't work very well on its own. I've got to admit, people say you could use a antenna, and I did detect hydrogen with it, but it wasn't terribly effective. So it had a much better second life as a waveguide for this particular telescope. Now, the other thing I know has been mentioned, and I mentioned it, but I'll mention other talks, but it's absolutely revolutionized hydrogen line observing for amateurs, is this Sawbird H1 from Newarlec, a Canadian firm. We're talking about £50 for one of these. I don't know, $50, $60. and it's got two amplifiers in it. It's got an amplifier, then it's got a filter, and then it's got an amplifier, a SAW filter, and hence the SAW bit. And that's just completely changed everything. And I think that's also worth mentioning recently is that companies are now starting to produce off-the-shelf equipment designed specifically for hydrogen line observing for radio amateurs. So clearly there's now enough of us to stimulate them to start making stuff, sorry. And then as far as the software-defined radio that I use, I just still use the RTL SDR version 3, and I've got a version 4 as well, as recommended in the Scope in the Box package. Again, about 30 or 40 pounds online, and it does the trick. I know people, and on discussion on the forum and on the Drake's Lounge, there's been a lot of discussion about the fact that these tend to vary in their performance over time, but as far as doing sort of basic mapping exercises, they work quite well. And as far as software is concerned, I'm a very big advocate of Ted's easy radio astronomy, simply because I think it is easy radio astronomy. Its biggest problem is that it works really well, analyzes everything fantastically, then produces 200 to 300 plots, and you look at them and think, what on earth does that lot mean? So your issue is trying to work out what is actually produced at the end of the day. But then Ted usually comes in to tell me what's going on, which is great. So I'm well away, completely free online, like most things in radio astronomy are. Another alternative mentioned at the bottom, which is actually mentioned in the Scope in the box package, is the SDR Sharp with its IF average plugin. That works too, and in fact, Easy Radio Astronomy will analyze that data for you. And I will, for Alex's sake, mention his H-Line 3D software that he's produced, which also allows some spectacular analysis to be done. And recently, we've been doing a lot of work, many of us using Renearn 3D to 3D visualize this data, and some really quite amazing pictures coming out. So here I'm going to just tell you what I was hoping to achieve with this solar cooker, mainly because, as you can guess, I probably haven't got that far yet. So with my ptarmigan array, this is an example of the map that I've been able to produce, the Milky Way, with two very clearly visible arms over the sort of 90 degrees that you can get these things to work. So this is what I'm hoping to mimic this with the larger solar cooker radio telescope, and also get better detection of that outer arm and possibly of another arm. Also on this is the ptarmigan array again. Mentioned before about Keplerian rotation on the left-hand side of our guest lecturer. Again, you can see there, for people wondering exactly what was going on there, that if we look at so this is Wikipedia data on the left-hand side, and rather than my data, and so it shows the planets of our solar system. And the further you go away from the center of the solar system, the velocity of these planets drops off, and that's what you'd expect if there wasn't any dark matter. On the right-hand side, you've got my data, and what it isn't doing is dropping off like that. It's between 4 and 8 megaparsecs. If anything, it's closer to a flat line, which is meant to be that smoking gun for dark matter. And what always amazes me is that if you look there, according to this, my actual measurement of the velocity at our level from the sun is only about 10% away from the velocity that's online. And this is me weighing the Milky Way here, which from 1 to 8 megaparsecs, which is quite a robust exercise to do with these little telescopes. Works very well. So that's great. So I was trying to do this with this new telescope. Unfortunately, I ran into a problem having set it all up very quickly, and that was that I could hardly detect any hydrogen at all. I'm going to say amazingly, I did detect some hydrogen, and in a second you'll see why I say that was actually amazing, probably more amazing than not really. And at the time I was really very surprised, because as you saw in that picture, this was actually sat right next door to the ptarmigan array, pointing in the same direction with the same type of setup, same type of computer and kit, etc. And whatever bits of kit I changed around, it didn't seem to make any difference. they just picture what a VNA is supposed to do. So Jason here actually introduced me to a VNA. I got to give him a lot of credit. Without him, I wouldn't have really achieved a great deal of this. But they can be used to test all sorts of different bits of kit in your system. Wonderful bits of equipment, and it cost about £50. So this is my personal take on what they do. So you get this expensive network Vector analyzer, but you get these little cheap things for £50 or so, so 50 to 100. The £100 come in bigger 4-inch screens rather than the 2.8 screen of the smaller one, if you want something that's easier to look at. But you can get software that will show it on your computer screen as well. And it allows you to actually take your telescope system apart, component by component, and check each bit to find out where you're experiencing problems, or even just to check performance. So we started off with my container there. I thought maybe that was going to be where the issue was, but in fact, I've got a standing wave ratio of 1.5 on that. Okay, it's not perfect at 1, but in the circumstances, I don't think it did too badly given what I made it out of. And certainly I should have been able to detect hydrogen. Then I looked at the Sawbird, and that's got a reasonably flat line at the top there in the middle, which is we expect the performance to be. You know, again, the reasonably good SWR, and I had 3 or 4 of these. I checked them all, and they all performed about the same. I thought maybe the quality control on those would be poor. So then I checked the coaxial cable and the connectors. This bit I thought wouldn't have any problems. So I started with my KMR 400. Maybe that those you know it's a rip-off basically of LMR 400. So I thought maybe a Chinese clone of that would be poorly made, but in fact that did really well with 2 decibels over about 10 meters run that I had. And these things were using SMA connectors to fit into things like the new Alex Sawbird. And I'd actually bought some KMR 400 that came with connectors already on it. And so I thought I'd be clever and get one rather than have to put a connector on myself. I'd buy one that had an N-type connector on one side that would make it easy to use with the other bits of kit I was using, and an SMA connector on the other end. And then I learned something I didn't know anything about at all, which is one of the problems with radio astronomy when you started off, which is what seems obvious to other people isn't necessarily obvious to you. And I discovered that there are 2 different types of SMA connectors, SMA and sort of reverse, I don't know what the P stands for, but reverse SMAs. And as you can see from this picture, one of them has the pin on the opposite side of the other. So the reverse SMA has the pin on the female side, and the SMA has the pin on the male side. So you can all guess what's going to come next. It turned out I was connecting 2 together, where it was a female SMA with a male reverse SMA. So I actually had no central connection between the 2 connectors, which is why I say that it was surprising that I managed to detect any hydrogen at all on the things. And as soon as I just put a simple adapter between the 2, so that we had a central connection, the reading on the nano VNA went down from minus 32 decibels to minus 2 decibels. So if you're using SMA connectors, make sure you're not getting these reverse ones. Apparently, they're designed for things like routers and things, supposed to stop you from mixing things up, but I don't know. So here's my solar cooker radio telescope when it was all finished. You can see there with the new Newelec Sawbird close to the antenna there. And here's just example. If you've never seen hydrogen being collected before, I've got a little bit of a video here just to show you. This is over like a 24-hour period. So you can see the signals coming in there and going up as we cross the Milky Way. Okay. Then comes back down again. Right. So a couple of things I did to try and just improve it a bit. I'd use, you saw these flat metal strut things from a local hardware store. So I've reinforced those with some wooden poles to stop them flexing, because I think that was affecting some of my results. The other thing is these solar cooker parabolic dishes come with a mylar coating, which gives the reflection. And I started off by just spray painting over the mylar, but found after a while that the paint just came back off again. So eventually I found that you can grab hold of the mylar at the side and literally just peel it off. And it's not particularly difficult, although if you buy one of these things, I'd recommend you peel the mylar off before you put it together, which makes, because they're quite big and trying to get around to the different petals to do it is a bit of a nuisance. And then you still need to spray paint it unless you live in Arizona or somewhere, because it is made just of sheet steel, so it does rust. So I recommend spraying it with a good paint. I'm using some aluminium and zinc spray paint to give it a bit of sacrificial metal in it. The other thing I've added in is this wooden stick that goes up the center of the antenna, which looks a little bit ridiculous on there, but that's just to give something that I can stick the inclinometer on to give a bit of a measurement of where it's pointed. And there's an example of the results coming through. Ted and I have been wondering why we got gaps on the left-hand side on this particular chart. We haven't worked that one out yet. But before it was there was some discussion about, does it matter if you're a few degrees out? You can see there that at the moment on this, I put slightly got the azimuth wrong that I'm putting into the software, and hence it's mapping the chart a little bit off the Milky Way. But easy rate astronomy makes that very easy to correct in analysis. And each of those green lines represents a different elevation. So if you follow the line across, that's a 24-hour. In my case, I go for a week at a time to get a better signal to noise ratio. But basically, it's a different single elevation, and then you change the elevation by changing the holes on the stick that you got it through, and then and I point them roughly south. The software will take any direction, but it's convenient to point south. And there's an example of the data coming through. And you can see, if you look up, for example, at the ANT RB TVT at the top, each of these represents a different part of the process, processing of data from the bottom, which is ANT raw, up to the top, where it's doing different parts of analysis in the software. But if you look at the top there, you can see that it goes up and down. Each of those cyclical changes is a single day. There's quite a lot of data in this. An example here of it mapping out the different data as a sort of cascade plot here. And on the right-hand side, you can see the software trying to define where the top of the data is. And you can see another problem, that we do have some RFI issues, which is creating some difficulty with its selection of the top of that data. And here's me attempting to, attempting to weigh the Milky Way, which is not giving me the straight line I would expect. So I took a little bit of work on this. And this is sort of an initial part of a mapping exercise with this, which is, it's got a way to go before it'll be as good as the ones that I'm getting from the Ptarmigan array. But hopefully I'll come back to Drakesland in a couple of months and be able to give a nice map that I'll be able to produce with it. Yeah. And so far, that's what I've got from attempting to work out where the dark matter, trying to demonstrate dark matter. So that's not doing anything. There we are. That's me done. Thank you very much indeed for listening to our talk.
Thank you, Andrew. Very good. If there's any questions for Andrew, we'll certainly add them online chat. He provided his email address as well, so shoot it. Thank you very much, Andrew. All right, so the rest of our day discussions are done. We have dinner in 11 minutes, so give us time to get over there. Enjoy your dinner. Get any ballots. Yeah. And get any remaining ballots to Bruce right here. You can be counting. And then Chuck, we have.
Check that out, make sure there's no ballots.
That's what you've been selected, right? Dinner, and then we can continue on with if there's a flea market or discussions up in the break. Enjoy the evening. So thank you very much. Tomorrow morning, 8 o'clock breakfast, 9 o'clock discussion start. Folks online, I'm going to go ahead and jump offline now. Thank you.
Thank you, folks. That was great.
Thank you, Ted.
I've got a question about Wednesday. What time is the speaker going to be on Wednesday?
Lounge up there to do the counting.
Could you ask that question one more time?
What time is the speaker going to be on Wednesday?
It'll be.
Do you understand?
What time is Peter going to be on Wednesday?
Oh, I
Pardon?
was. On Wednesday.
Oh, you want to grab?
What is the schedule?
Okay, we do it.
Which speaker?
What is the schedule? Let's read that off.
10 o'clock, okay, thank you.
Yeah.
Very good. Apparently, the Wednesday schedule has been increased. We have an additional speaker than what was emailed out. So we can enjoy that on Wednesday. It starts at the same time, I guess, 9 a.m. Eastern. We'll see you folks tomorrow, 9 a.m. Eastern here for Tuesday.
Thanks, Ted. Thanks, everybody. See you tomorrow.
So, Andrew, can I ask you a quick question?
Yeah, sure.
Before you figured out the RPA, SMA, and SMA, did you have the LNA amplifier up at the feed?
Yes. Oh, I don't know. Actually, that's a good question. I don't know.
Well, the reason I'm asking is because isn't the feed sending the I'm sorry, isn't the coax sending up the power for the LNA through the from the RTL SDR? It's sending out the power to the LNA through the coax, correct?
Yes, you're right. So I probably didn't have it up at the feed. Then that was probably later on.
Because we
Okay.
were asking you whether the LED was on the amplifier.
Yeah, well, I would have checked that.
I see. So you had
I've learned that the hard way in the past with the ptarmigan array when I first got it. I'm paranoid about little white lights on the sawbirds these days.
so you must have had the LNA right by the RTL SDR, correct?
Yeah, in fact, if I remember back, I think then I was still at that point, still powering the LNAs separately using a separate power supply.
Oh, okay, okay.
I was doing all of them that way. I think it was later that when after I got sorted out that I decided to after some discussion on Drake's Lounge, I think it was that about problems with power supplies. That I decided that it was worth. I think Wolfgang might have said something actually about some problems with them. So I think I decided I'd swallow it and go down the route, because previously I'd had them all separately powered because it avoided me having to worry about trying to make sure that I remember to turn the bias T on, because I would tend to forget to turn the bias T on when I turn the computer on. But then Ted modified Ezra so that you could actually put an extra parameter on the EZ coal line so that it turned the bias T on. So I use a batch file to run things, which means I don't have to think about anything. And so it's all built into there now, so it automatically turns it on.
I see. So you were just you weren't using an external bias T, right? You were just directly powering from a power supply.
I was. Yeah, well, you don't need an external bias T for the new elec, because you can plug a power supply directly into it. For safety, because it sends the power back down the coax towards the SDR. Depending on the SDR, that could potentially damage the SDR. So for safety, you could do with putting in a bit of an isolator. What do they call these isolator things you put in that?
Well, a capacitor, a block, but
Yeah.
it worked just fine if the connectors didn't touch anyway. So yeah.
Yeah, well, exactly. But
Right.
I tend to find the RTL SDRs don't seem to care either way. But I just for safety, put as a DC block. That's right, you call it DC block in.
Right.
But just to protect it from the power. But nowadays I don't. I've taken all the DC blocks off, and as I say, now power's down the coax now.
I see. Okay. Well, that sort of answered my question. I was just curious if besides not having the connection on the coax, the LNA was not being powered, and so that was the
Yeah,
reason for
it would have been can guarantee it would have been the first thing that I would have checked, because
Okay.
when I started doing all this stuff for the Ptarmigan array, I had some times where nothing was coming out of it until I discovered that the new alert wasn't on. And when you've sort of waited 2 or 3 days for data and come back and there's nothing, it's very, especially at the beginning, it's very frustrating. So I sort of, as I say, quite a paranoid way started to do, especially when I was, because it was generally because I was forgetting to press bias T on the computer. I ended up putting labels over everything. Remember to turn bias T on. Turn it on.
Well, it's nice that the LNA has a little power LED there, so you can always make sure that at least it's getting power.
And actually, from where it is now, I can see it in the house.
Fantastic.
At night, anyway, I can see it.
Have you finished peeling off all of the mylar?
I have now. Yeah.
And then just repainted underneath it, correct?
That's right. Yeah, just respray painted again.
Okay. And does that seem to help with the rusting problem?
Oh yeah, it works very well. Yeah, I was. We have a local sort of ultra cheap sort of supermarket thing, which is one of the German ones, come over to sell very cheaply, and that they had a bit of a sale on spray paint, so I stocked up.
About how many cans? About how many cans do you need to do the solar cooker?
Well, bear in mind you got to do front and back, so I'd probably say 4.
About 4. Okay.
Yeah, which depending on how much you pay. I mean, here, spray paint cans sort of full price about £13, so I could have been paying the same price as the as the dish, but we have quite high humidity levels, so if you don't do something, then it's going to just disintegrate. So I managed to get about £4 each of these cans.
So
So
your
that's
paint drives one of my questions. If you're spray painting, are you getting anything on that pretty grass out there? Where are you doing your spray painting?
Oh,
In
it's
your
on the
neighbor's
terrace.
yard?
Neighbour's yard. The spray doesn't go that far. It's up on that wooden mount, so sometimes it spills over a little bit onto the bits of wood around the mount, but not really.
Well, you had
On
to
the
paint the
grass.
mounts too, so the same problem, I think.
Yeah, well, the mount's roughly the same color, so it doesn't matter too much.
Okay, anyway, you got away with it. Okay, good.
Well,
Yeah.
I'm just curious because I've purchased one of the solar cookers. I haven't assembled or anything on it, but I live very close to the to the ocean, about just 4 or 5 miles. So the corrosion out here is pretty bad. Not only the humidity, that we get a lot of humidity, but also it's because it still has some of the salt, I guess, from
Absolutely, yeah. I mean,
seawater. Yeah.
I've been down to sort of Cornwall and stuff in the past, and you see cars in people's gardens and things that look like absolute rust buckets due to
Yeah.
both. But I mean, again, we had some discussion online about it, and I forget who it was, but one person certainly suggested that you'd be better off using one of these specific anti-rust paints that you can buy. I suppose even if you have a paint that adds a millimeter or 2 to the thickness of the dish, if we're talking about 2 centimeters depth and still be within 10th wave, it probably doesn't matter too much. So you could probably do that. I went for spray paint because I wanted to minimize any deformation on the dish. Plus, to be honest, I was also ridiculously a little bit concerned about the look in my garden. I wanted something that looked a bit sort of neat, so nice, neat to the grey colour.
Right.
Because that was the next question: is there some advantage to going white so that you reflect any sunlight off it, so you don't get any deformation from sunlight if it absorbs any of the sun? But I don't know.
Probably that neutral gray that you have is about as good a compromise as you can probably go for. Yeah. Well, that's yeah, that was a great idea. I'm glad you kind of came upon that.
Well, yeah, thank you. is an interesting project. There is another issue which I haven't mentioned, which is actually mounting it. The back of the dish doesn't have a very easy mounting point. The sort of mount that comes with it is just like a simple tripod thing with a single stick that goes up. It is not meant to be stable in any way because it's the way it's used. So you have to do something else. So because there isn't a nice neat place to connect your mount, connect to the mount, I'm having to do a real. Well, as Ted and I have found out, we've come to realize there's a little bit of flexure in the scope as it moves up and down. So when I finish this particular mapping exercise, I'm going to revisit that and see if I can attach it to the wooden frame, but in a better way.